All right, welcome to our live build of the Simple Air Sensor with Public Lab. So this is the last installment of our week of events on air quality data. Earlier this week, we had some presentation on resources for community scientists who are collecting air quality data and interested in visualizing and communicating it. And then we also heard from a couple guest speakers yesterday on community air quality monitoring projects that they're doing in their communities. So right now we're going to look more closely at a tool for collecting air quality data and specifically particulate matter. So particulate matter is airborne dust and particle pollution. It comes from burning fossil fuels, so from like vehicle exhaust. It comes from mining or wildfires. Those are just some examples of sources. And yeah, the tool we'll be looking at will be examining, will detect that kind of particle pollution. So we'll do some introductions first before we jump in. My name is Jeanette Lim, and I'm the research manager at Public Lab. I'm calling from Bellingham, Washington. And I'm excited to learn about some of the things we can do with the Simple Air Sensor once we've got it built, which Vanya is going to help us with. So I'm going to pass it over to Vanya for an introduction.
Yeah, hello, I'm Vanya. I'm the Research Air Curation Fellow, Air Research Curation Fellow with Public Lab, and I'm calling from Los Angeles, California. And I'm also excited to see how we can get data out of the sensor, so beyond just the colored LEDs that we'll see later on.
Thanks, Vanya. Okay, so we will start with building the Simple Air Sensor, and then we'll talk a little bit about using it to see essentially what air quality data looks like and some ways to read the data and then also visualize it. So I'll let you take it away, Vanya.
Awesome. Let's see if, let me know if the screen shows up. Awesome. So yeah, so this is the Simple Air Sensor. You can see the different parts. There's not that many parts. Hopefully you can see all of them. And then so this is the sensor itself. This is a Plan Tower 5003 sensor. So this is what actually like takes in the air quality and converts it to some like digital information. And then this is the Arduino Nano, which is essentially the brains of the device that takes in the information from the sensor and then does some calculations with it and then converts it to a color for the LED light. And then we have the breadboard, which is kind of what we use to connect everything to each other. There's also an LED, which this is a multi-RGB LED, so it can do multiple colors. We also have a connector cable. This is what helps connect this air sensor to the breadboard and essentially connect it to everything else. And a resistor, which you can use to kind of just elongate the life of the LED. And you should also have gotten a USB cable that basically plugs into the Arduino and you plug into a power source or laptop. Cool. So first step is to push the Arduino into the breadboard. You can do it. Ideally, it would be flat. If it's too hard, it works even if it's not completely flat. It's flat now. And then, so the Arduino has logic that's already pre-programmed into it that basically takes the information from Plan Tower, does some calculations, instructs the LED to change color depending on the sensor inputs. And then the second step is, this is optional, but this makes the device a little more compact. There's a sticky thing on the back of the breadboard. You can just unpeel it. stick it on top of the sensor. And the way I set it up is that the USB port is on the right hand side, or the side opposite of this thing. Yeah, so once you've stuck your breadboard on top of your sensor, then you can take the connector cable and connect it to the sensor. So there is a space, so this little area is where you connect the this is where you connect the connector cable. The direction of it, it's either like this way or this way, right? And then the way I did it is the two of them that are on the side that are close, the two long ones on the side that are next to each other. These should be facing into the middle of the sensor, towards the middle of the sensor. And you just push it in. So one note about this connector cable is that at least I got mine unstripped, so the plastic ends went all the way basically. So to make sure that the data and power actually flows through, I strip the cable, so you can do that with cable stripper or your teeth apparently, or what I use was safely use a small flame. And you can use like a screwdriver or a pen if you can put something in. Okay, there you go. And then so now you have this in here. The next step is to connect these cables with basically stick it into the correct pin in the breadboard. So the way this works is that because we set it up so that the two long wires that are next to each other are towards the middle, then you can take the rightmost one if you're looking at it from my angle. But the one closest to the middle of the power sensor, this one is the 5 volt one. So you can go find the 5 volt pin. Small. But if you can't see it on here, you'll see a 5 volt on here, one of them. And so you just make sure that you plug in the black one, if yours is black, but the innermost wire into the 5 volt. Make sure you stick it in tightly. And then the long wire that's right next to it, that's the one that you stick into the ground, which is to the right of the 5 volt one. And then the last one, this is where you have to like cross over to the other side. But this is the one that goes into D2. There's ground, D2, D3, and numbered all the way to D12. D2. Somewhat sturdy. So now this is what it should look like. So the reason there are different pins is because the code that's pre-programmed into the Arduino has to refer to the variables, so that it obviously doesn't know what is sensor, what is LED. It just treats variables as variables. So you're assigning this sensor to the D2 variable, which is going to be calculated in the code of the brains. And next step is to connect the LED. So this is where you have to examine your LED, and you'll see that a little bit hard to see, but there is one of the legs that is like longer than all the others. Okay. This one. Yeah, so this one you can kind of see. This one is the longest. So the order of the legs is the red one, just the long one, and green, and then blue. The long one is the one that needs to be connected to power. So the order is long one goes to power, the red one, which is the outermost one that's closest to the long leg, that one goes into D4, and then green, which is the middle one that's closest to the long leg, that goes to D5, and then the outermost one that's furthest away from the long leg, that's the one that goes into D7. And the way it goes is that it has to go, basically it straddles the Arduino, it goes across. You can try to put them all together, and then the long leg goes into a 5-volt one, which is, you can pick a different box to put it in that's next to the 5-volt, but it should be next to your first wire that's on power sensor. This is kind of tricky, so you have to get all of them at the same time. It's a little bit easier to do the three variable ones first, easy ones. Oh, so these are now stuck in. So this is the completed view of the sensor. This is technically done. So if you reverse the LED by accident, you'll see that you won't get the bright colors. So you will be able to tell. And your kit may or may not come with a resistor. And this is to kind of help prolong the life of the LED. In theory, there should be one resistor per leg of the LED, because they're like different voltage, and then you get into electrical engineering calculations. But short TLDR is that you can, a simple way is to stick it into the same box as the power, and stick it in the same box as the form. And that's the red one. So the red is the most likely to get burnt out. This is one way you can use the LED. You can also use it without the LED. It works. It worked for me. But yeah, FYI that you can add one or more resistors. And then, so the last thing is to plug in your USB to a power source. I can plug it into my laptop, but I'll use the power bank. Okay, cool. Well, I'm not gonna show up that well on the webcam, but trust me, it's green. So yeah, that is the simple air sensor.
Thank you, Vanya. Okay, we're back. We just did a little bit of monkeying around there to take care of some background noise, but we are back. We are ready to continue. So thank you, Vanya, again, for showing us how to build the simple air sensor. So I've got mine here already assembled, and I'm going to switch to an overhead camera so we can check out. There we go. There's me. And I know this is far away, but I wanted to, when I had the camera closer, it oversaturated. You kind of saw on Vanya's too that it's a bright LED. So a little bit further away makes it a little easier to see. So I'm going to plug mine into my computer via the USB cable. And you'll see it turn on there, and it's green. Okay, so the LED there is green. And I'm just going to demo with some matches what the color change is like when we use it, use the simple air sensor. So on this side of the, where am I looking here? There. This is where the air goes in to get detected by the particle sensor in there. So I'm going to get this match. And then light it right here and blow. And you'll see turns red. And the LED colors are green and yellow and red, indicating the relative air quality or relative particulate matter concentrations. So green being low, and then yellow being medium, and then red being high, relatively high. So this is like an instant visual of the relative air quality that you get from the light. And as the air clears, then you'll turn, this light will turn back to yellow and then back to green again. But if you are looking for more quantitative information, there are a few ways that you can get numerical data from the simple air sensor. So I'm going to turn the video back up here to me. So these ways to get data, quantitative data from the simple air sensor do take a little more work. It requires some software and some code. So we can see, we're kind of just jump ahead so that we don't end up coding on a live call. But we're going to jump ahead and see how we can read data from the simple air sensor, what it looks like, and then let you know that there is an activity on the Public Lab website, which walks through step by step how to set up that software and run that code so that you can visualize the data coming from the simple air sensor. So I'm going to jump ahead, like I said, and open up the free Arduino software. So this is what allows you to communicate with the Arduino board that's on the simple air sensor. I'm going to open the software and then share my screen so that you can see what it looks like here. Share. Okay, now hopefully you're looking at a whole desktop now. So you're seeing everything. Yeah. The reason I'm doing the whole desktop is because there's going to be another window that pops up. But basically, what you're looking at here is the software for the Arduino. They call an integrated development environment, and the tool that we can use to visualize the data that's being read off of the simple air sensor Arduino board right now is up here. So this is the Arduino menu. And I go to tools, and there's something called the serial plotter. So it uses, whoops, what's going on? This is funny, board at not available. Interesting. This is fun live debugging, apparently. Okay, well, let's do this. Board is not available. Maybe I should have followed my own. Let's see. Port. Okay, so what I gotta do here is I gotta make sure that the board is actually talking to the computer. So over here, we've got Arduino Nano, that's correct, and a processor using the old bootloader, correct. The port, okay, this is the serial port I need to select here. So now it's talking to the board. The computer is talking to the board over serial. So now we're going to try that again. So we go tools and serial plotter. Aha. Okay, now over here, this window now, this is live data coming from the simple air sensor right now. So you can see, I'm going to lift it up. It's still red, which means that the particulate matter concentrations are still relatively high. But now hopefully you're seeing this graph being populated in real time, where we have 3 different lines that are indicating 3 different particulate matter sizes. So there's PM 1.0, PM 2.5, and PM 10. And these are some pretty common concentrations of, pretty common sizes that we're interested in when we talk about particulate matter concentrations. And as the air clears, the lines we see are coming down. Aha. Sorry, see that? Hey, Mike, welcome. We're just looking at some data from the simple air sensor in the Arduino software and the serial plotter there. So this is, how you can use no extra hardware than what you already have when you have an assembled simple air sensor to visualize some real-time data coming from the sensor. So I'm going to stop sharing my screen now.
Are you able to extract it into like a JSON or tabular format?
Yes, good question. Okay, let me share my screen again and I'll show you. Not quite JSON, but you can also, I'm going to close the serial plotter. You can also open up what's called a serial monitor, which will then display the data in tabular form. So now you've got the numbers here. So you see PM 10, 44, 46, 47. I haven't gotten as far as to figuring out like a neat way to get this data other than to wait till you're at the amount of data you're interested in and then copying and pasting it into like a text file or something. But there's I'm sure like a much more elegant way to do that. I just haven't gotten there yet. Yeah.
Cool.
Okay.
Yeah, that's super cool. Thank you for that demo. Yeah, super awesome demo of getting data out of the sensor. And I can talk about what the data could look like, or what data from this type of similar sensor looks like, and then before, after, some simple data cleaning steps, and then do a quick demo on the plotting data that you extract. So just to note, this is not the data that's directly coming from what Jeanette just showed us. This is from a very similar type of sensor, but with a different brain. So instead of Arduino, it's using Raspberry Pi, and a slightly more advanced version of the plant power sensor, but essentially collects the same information. So let me share my screen. First thing you need to do when you get this data is to convert it into a format that's pretty easy to explore and graph. Let me share my whole desktop here. Be saving a bunch of rocks. And yeah, so this is what the file looks like. It looks a little intimidating at first, but you'll notice that it's a .json file, and JSON is just the way to store data that involves like a bunch of nesting. And you can open up the file in any text viewer. I'm using VS Code. You can use Notepad if you wanted to. VS Code just has VS Code, and stuff like Sublime Text has a little bit better like color coding, so you can better see the different types of like values in the data. So you'll see there's a bunch of nested things. most of these are not that important. The most important things are, you don't have to understand every single piece of it. Most important things are metric. Um, so this is what PM it's looking at. So you'll see metrics, and these are, okay, these are pretty basic. This is the model of the sensor that we're looking at, Plantar S5003, and this microns is the most important part. This is PM 1.0, and for PM 1.0, these are the values that it's reading, and we can get into exactly what these numbers mean, but this is essentially kind of the air quality. And like you saw in Jeanette's example, there's PM 1.0, 2.5, and PM 10. So you might be wondering, so where is PM, where are those? So if you scroll far enough, you'll see, oh, look, there's something else that looks very similar to what we just saw. And it's the main difference, the only difference is microns PM10. And you can expect that there will be a similar thing for PM 2.5. So cool, this is what it looks like. And then the next question is, now how do you get it into a format that is like human readable? And that part involved a little bit of scripting that I won't force you all to look through code. But if people have questions, we can take that after. Yeah, basically there I'm using open source software called R that's does involve a little bit of scripting, and there are packages that help you extract data from JSON format. So so yeah, so that's kind of how you get, so that's kind of, there is a step to getting from this format into a tabular format. And so once you have it in a tabular format, you can see, this is eventually what it will look like. And then, so you'll see for each PM type, there's date, hour, measurement. So this is already aggregated, but what we got from here is actually 1 reading per 15 seconds. And the way that, so you'll notice that this has a date column and this does not, except this actually does. So let's get into the values. So what are these values? So the most basic values that we need for any air quality sensor is like when it was recorded and what the air quality value was. So there's one of the numbers, it's like a very big, like million or billion number, this really long number, and then like a seemingly number that looks like it's between 0 and 100. So my initial reaction was that this like 0 to 100 number is the concentration of PM, and then this would be the time. And obviously this doesn't look like normal human readable time formats. And I happen to like recall vaguely that there is such thing called Unix time, which is the number of seconds since January 1st, 1970. So this is how some computers record their time, and record and display their time. So I tested you converting Unix time to human time, and it does look like it works. The readings end up with, so these dates end up being between like December, November 29th and December 3rd, which is the correct dates that the readings were taken at. So this semi this semi guess was ended up being correct. So that's how I was able to get this number into a date. So converting from Unix time to normal human time. And one other thing. Yeah, and then so you can take a look at this. And what I did was also look at some data quality. I checked that all of the records were available. So for every hour, And every 15-second increment within the hour, I confirm that we did see data. So that's a good sign, not missing anything. And then I also checked for a number of zeros. There were a fair number of zeros. I think more than half of the data set was zero, which is not necessarily an error, but it's something that's useful for you to understand when you're looking at data like zeros. And also I checked for negative values, which would definitely indicate an error. It was good that we didn't see any negative numbers. So the lowest number is zero. And there, I also checked for kind of repeated values. So when the same number was kind of repeated over more than one reading. And that was, again, not necessarily errors, but useful to understand and know. And because it's reading so frequently, we do expect that there would be pretty similar readings within 15 seconds. So, and again, like I mentioned, the readings were originally at 15 seconds and I aggregated them up to hourly just because I thought just because it helps with the amount of data and it's easier to work with a little bit less granular data. So now that we have this table, we can graph it and do a quick demo of how we visualize this data. So what I'm using here is RawGraph. This is an open source software that does simple graphing, and go use it now. It'll take you to this interface where you can load in your data. You can paste it in, or you can load in a file. So I'm going to do that. And so you'll have to be aware that, so you slow down and look at, okay, this is what it can take. And if your file was in Excel, you need to convert it to CSV. Cool. And so here you're seeing that, okay, cool, it loaded in. And the first thing you want to do is double check that the data types are correct. So this little gray circle on here will tell you what RawGraph thinks your data is, and you can correct it. So this looks correct. This is not correct, but we can ignore this because we're going to use the date hour column. Our number, that's correct. Measurement is a number, that is correct. This is, it thinks it's a text, understandable because there are columns, or there are colons and dashes, but we want it to be an hour or a date. So we'll look for the format that matches this, and it's this one. Great. Okay, and you see that it changed and it's now correctly reading as a date. Okay, I think it looks good. And so now we can choose a chart. And the easiest chart for these types of for kind of time series is line chart, basically like the one that we saw in Jeanette's example, except this would not be real time. And then x-axis, what goes on the bottom is date, except we want date hour. And then y-axis is what we want to plot is measurement. And we can do the average. And so right now you'll see that it's plotting something, but we know that we have three lines. We need to have three lines. Needs to be PM1, PM2.5, and PM10. The way you get those lines is there is a handy lines box here where you can put in microns, which is telling you the size of the particulate matter. So now you have three lines, but we also want them to be different colors. So you can drag the same thing into the colors. Now you'll have three different colors. Cool. And then you scroll down even more, and you can customize kind of like the width and height, and I want to make it slightly smaller to fit on the screen, um, even smaller. Yeah, so you can see this, and then you can change margins, and I do want to show legend, so you turn it on. I can turn it on here. Yeah, so you can see microns and the color that represents, and yeah. And then you can customize like the colors, like what color scale do you want? I think these colors work. Axes can turn on ticks, on or off ticks. Um, and then you can show the titles or series titles, and the chart you can turn on or off like dots if you wanted to see dots. And at the end you can, and then you can download into different file types. I'll just do JPEG. You can save it. Put my download folder. Cool. So you have like a downloaded graph of PM. And obviously there are more things you can do, like change the axis. You would want to label this. And the way you know what this y-axis label is I went into the specification sheet for the air quality sensor, the plant tower, and then it says that it measures in micrograms per cubic meter. So that would be your y-axis label. And that's it.
Super cool, Vanya. That was an incredible amount of information going from like a bunch of pieces of hardware to like you've got a graph of data. So yeah, thank you for walking us through that. It was really neat actually to see you kind of the things that you think about in cleaning data to get to this graph that, you know, we probably see graphs like that a lot in like publications and newspaper articles, but to now see kind of like some of the analysis and working that goes into it, I think is pretty neat.
It's like the iceberg picture.
Exactly, the iceberg of air quality data. Yeah, exactly. Yeah, well, we have 10 minutes left on this call. So I just wanted to point out there are some links that we'll share associated with this video about some of the tools we're using. So like a link to raw graphs. And then also Vanya has created a pretty neat comparison table of different data viz tools of which on which raw graphs is there, including some other ones that include some proprietary software, all with sort of like different ranges of ease of use and some different features. So it's a neat tool to go look at if you're looking for a bit of breadth in available data viz tools and what to look for. So I actually had a question for you, Vanya. We could just do a little like Q&A kind of back and forth. Yeah, so my question for you is, since you've gotten the simple air sensor, what have you found it kind of useful for? Like what have you been using it for, and what could you see yourself using it for too?
Yeah, I've only built it for like 2 days.
Yeah.
I've turned it on while cooking, and it's interesting to see like the progression of like going from like green to yellow to red as your cooking intensifies. And if you're like baking something, um, our house uses natural gas for cooking, so you can definitely see the impact. And even after we like turn off all our stoves and we like start eating dinner, obviously the particulate matter is still in the air. So it's interesting to see like how long it takes for it to fully like dissipate. And also like walking around like the house and seeing that, okay, it's kind of like, is it isolated just in the kitchen, or does it get to like our rooms? And pretty interesting to also like take it to, even in our kitchen, taking it to like a window, putting it next to a window, and it'll turn green. So you can really see the impact of ventilation and like why that's so important for not just kitchen, but anywhere that might have bad air quality. So that's really interesting. I like when I visited my friend, I like took it to their place and they have good air quality. But I'm like I'm excited to get more like numerical data out of it and try to like reverse engineer the colors.
Yes, definitely. Yeah. So there is, as Vanya was saying, the Arduino Nano that comes with the simple air sensor when you buy it from the public lab store comes pre-programmed. And that code for that program is available online on the public lab website. So you can see it, you can look. Yeah, so the reverse engineering, you can find the code there for how the colors are mapped to the concentration levels. If you can understand, I didn't quite understand it, but it's there. Yeah.
Yeah, it'll be a fun thing to just try to understand because I know that I was trying to look up like how to extract code from Arduino, and basically the answer is that it's not really possible.
I looked up the same thing. Yeah, it's a one-way street. This is one thing that I've learned. I've learned a lot of things about Arduino the past 2 weeks, but one thing I learned it is you write to the Arduino and that's it. You have
Yeah.
faith in what's on there and you can't really see what's on there. Yeah.
That's why you should save your sketches.
Yes, yes, save your code, save your sketches for sure. Yeah, I had a really similar experience with how I use the simple air sensors around the house, especially cooking, because I was just interested in seeing like, what are different ways that I cook, like how did they manifest on the simple air sensor. And one thing I really like about it is its portability. It's like this cute little thing that if you have a portable power bank, you can carry it around and see like different rooms. And I had the same revelations, like how long it takes for air to clear. Just like that match that I lit at the beginning of this session. It was when I unplugged the simple air sensor like 10 minutes ago, it was still red. So it takes a long time to clear the air. And I was noticing the same kind of thing after cooking as well. So yeah, and I also really like, I do like this ability to get quantitative data off of the sensor with a little bit more work. Also, just the instant visual, I think, is really helpful for things like showing folks, like you said, you took it to your friend's house, like kind of an educational setting, like showing people like how you can see right away how air quality changes.
Mm-hmm. Yeah, it's like different from seeing those purple air maps where you get similar information. It also is like different colors of good, bad air quality, and then but it's kind of like so portable that you can see. You can also understand like the minute differences between air quality within space, so that you like really understand that one EPA sensor in the whole city is not enough to understand air quality in a city, because like even in a single household, it can vary so widely.
Yes, totally. Yes, that's a really good point. Yeah, exactly. Yeah. Do you have any questions for yourself or myself?
Yeah, just going off of like things that you learned about like Arduino and like anything else that you found like surprising or wanted to share about just digging into Arduino.
Yeah. One thing that one big takeaway I had is, I was an Arduino novice when starting with this project of trying to read data from it. And I did have help with it from someone who's a bit more familiar just with like coding environments in general. One thing I learned from that person was that when you encounter an error, which it happened a lot to me, there's just like this program not found, this isn't working, that isn't working, is that you don't need to know what those mean in the moment to be able to work through this. You can actually just like plug this into a search engine, because right now there's a lot of information from people who have used these like well-established platforms. And you plug that in and you can find like someone who has asked the same question. Maybe it's on like Stack Exchange or something, and then look for answers. And we work through a lot of answers through a lot of issues that way. It's just like searching for the error. So I didn't know that that's like a thing you do. I encountered an error and I was like, I don't know what to do next. Like I just kind of like stopped in my tracks. And I realized like, okay, you can actually just like search for it. Which I'm
Yeah.
sure varies depending on like the complexity of the program. But for this one, which is like fairly succinct, I would say, the program that's written on the pre-programmed Arduino for our purposes, it was enough. Like there was already issues out there that had been covered and other people had posted about.
Yeah, that is a big thing. Googling is like not even a joke.
Yeah.
Like Stack Overflow, Second Change, like they are resources, and like I use them a lot, and I know like coders, like people who do code, they use them a lot. So it's definitely a valid resource. And I think one thing about like open source tools, maybe not like Arduino specific, but for like the different types of visualization tools, you will find different levels of support available based on one, their user base, and also to like the organization that developed it and how much resources they have. So something to be aware of when doing like any like using any tool is that there are people out there that can help you, but the number of people that are out there like depends on how many people are using the tool.
Right. Yeah, exactly. Yeah. If the community of support is there, it's going to be much easier to figure out how to use it. Yeah. Yeah, definitely. Yeah. Well, we can wrap up here. Again, thank you so much for showing us from start to finish how we can use the simple air sensor. And yeah, we'll have some links to go along with this video for the instructions that we followed and various steps of this whole call and more information on the simple air sensor. And then, yeah, we will hopefully do another one of these live builds again with another piece of hardware.
Yeah. Thank you, Ned, for the demo and for demo of the real-time data plotting. That was super cool.
Yeah, thank you. All right, take care.